Hello everyone, my name is Karan Singh Katoch and I will be teaching CSAT to all of you. I have worked with many universities earlier. Over there I used to teach reasoning and aptitude. I have trained around more than 1,000 programs and from 2017 onwards I am completely that is CSAT. So guys, I hope you know about this, you know the full form of CSAT, obviously, because you people are appearing for UPSC. So CSAT stands for Civil Services Aptitude Test. But if you go through the syllabi of UPSC IAS, you will not find such word. CSAT is not present in their syllabus. This paper, the name of this paper in their syllabus is Journal Studies Paper 2 of preliminaries exam. And see, I know it might possible that you lot of you know about how this paper is going on, how many questions are there in this paper, and how many hours are there for completing all the questions. But still, if you are new students, then I would just want to tell you, this paper consists of 80 problems and the total marks are 200. Right? And in this paper you will find question based upon reading comprehension, right? You will find questions from aptitude. Aptitude, for example, you will find question like A can do a piece of work in 20 days and B can do a piece of work in 30 days, then A and B together will do that task in how many days. You will find problems of reasoning like A is the father of B and B is the son of D, then how this A and D are related to each other. You will find question on syllogism like some A are B, some B are A, right? Then some A are C, then tell us which conclusion will follow, right? You will find conclusion like all A are B, no A is B, right? So, but the thing and the best part of this particular exam is this is only a qualifying paper. This is qualifying in nature. Meaningly, out of 200 marks, you just have to score 33%. That comes around 67. Okay. So 80 problems, 200 marks. So if you do the maths, then you will find that every problem is of 2.5 marks. So whole and sole you need to do 28 questions correctly in this exam, and if you are able to do that, you can crack this exam very easily, right? Okay, so I have written all the stuff in the PDF also. See, qualifying in nature, like you need to score only 33% marks, right? And there will be objective type question, multiple choice questions, right? There will be a question followed by 4 different choices and you have to choose one. Okay, and next part is it is mandatory. Meaningly, if you want to appear for the mains, then you need to clear this exam. You need to score at least 33% marks in this particular exam, right? And nowadays this CSAT has become a phobia. Right? A lot of people, like they just want to run away from this particular subject, but this, like, scoring 33% marks is not that difficult. If you read the concepts properly, if you learn the shortcuts properly, and if you are disciplined person, then definitely we can crack this exam very easily. Okay. What next about it? See, if you want, like, talking about the pattern, the trends, see, from 2017 onwards, if you pay this data table carefully, then 2017 onwards, see, 26 questions, 2017 onwards, please pay attention to the questions that are appearing from this particular part of CSAT. Basic numeracy and data sufficiency, there were 26 questions in 2017, then 20 problems in 2018, and then you can see the increase Like examiner is more interested in problems from aptitude, examiner is more interested in problems of data sufficiency. And if you pay attention to the same trends for reasoning and data interpretation, they are decreasing, like there were 34 problems in 2018, then 21 problems in 2019 and so on till 2023. This problems of reasonings are very few. But if you talk about your reading comprehension part, this part is almost constant. There are generally 20 to 25 to 27 problem every year from reading comprehension part. Okay. So this is all about trends. I have segregated all the question topic wise also. So if you pay attention to this table, you will find there were 13 problems in this year 2023. There were 13 problems from the chapter of number system only, right? And if you like for UPSC students, NCERT is the foundational books. So if you pay attention to the mathematics books of 6th class, 7th class till 10th class, in every class you will have a part of number system. So that is why this particular thing is very, very important. So I want to start with number system today, but before that I just want you to get acquainted with all this stuff. Okay. After that, if you talk about this reasoning part, then a lot of problems are from cube cutting, then there was one problem from puzzle. So this is the data for 2023, one problem from repeated series, right? This is the information. Okay. And this is reading comprehension, 27 problem in 2023, 27 problem in 2022. Okay. And okay, if you people are smart enough to learn all the concepts of my class and all the tricks of my class, and still you find some time to learn, some time to study this particular subject on your own, then what book you should follow? So for quantitative aptitude, you can follow book by R.S. Agarwal, and if you have finished this thing, then you can jump to this Quantum Cat by Sarvesh K. Verma. Okay. For reasoning part, you can follow R.S. Agarwal, verbal and non-verbal, and then there is a book of reasoning by Arihant publication also. For reading comprehension, A.P. Bhardwaj is good, and this book comprehension and decision making problem solving by Disha publication is also good. Okay. Now further, so let's talk about one of the very, very important chapter of CSAT, that is number system. Although appearance wise this particular topic is very easy, but sometimes there are problems in the exam that are very hard to handle, right? Okay. So let's start this chapter from the very basic. So the first thing that we should learn under this is the classification of number. I hope you all are well aware of what are natural numbers. You all are well aware of what are whole numbers, well aware of what are integers, huh? So let's start with natural numbers. So what are natural numbers? I hope you all know. Natural number meaning all counting numbers. For example, if I want to count how many students are present in my class, how many employees are working in this organization, how many people are there in India. So this is when I want to count something, I use natural numbers. So all counting numbers are natural numbers, starting from 1, then 2, then 3, then 4, and this goes on till infinity. So what are natural numbers? Natural numbers are all counting numbers. I hope this is visible to all. Yes, technical team, is it visible? 1, 2, 3, 4. Okay. Now, so let's talk about what are whole numbers now. See, all counting numbers and 0. If you include the digit 0, then the collection of all counting number and that 0 is called whole number. Okay. So in case of whole numbers, you have 0 in it, you have 1 in it, 2, 3, 4, and this goes on till infinity. So all counting number plus 0 is a collection of whole numbers. Now, I have a question to all of you. See, generally when we learn things, when we learn numbers, we want to go with natural number first, right? And then we learn whole numbers, right? And in whole numbers we have included 0. And I hope you people know that 0 was discovered by Aryabhatta around 600 BC. Sure. Then please tell me, if this 0 was discovered by Aryabhatta in 600 BC, then how would people have counted 10 heads of Ravana? And Ramayana exists before 2000 BC. Like there was Ramayana, and then Mahabharata. Who counted 100 Kauravas are there? How they counted these things if 0 was invented around 600 AD? Are you getting it? So basically the point over there was they have a different way of counting numbers. They use some different things. Okay. Now, so talking about integers now. In integers, what we do, we include all the negative values, 0, all the positive values, and this goes on till infinity. So collection of all the negative values and all the counting till infinity is called integers. Now please guys write down very important aspect, very important aspect of these three classification. These three classification, the one is and that part is, see, in whether you talk about natural number, you talk about whole number, you talk about natural number, you talk about whole number, or you talk about integers, these are complete numbers. These are what? These are complete numbers. Complete numbers meaningly they do not include any fraction. They do not include any fraction or any decimal. So they are complete numbers in itself. For example, I cannot say 2.5 children are present in my class. It is not possible. I cannot say 1/3, like 1/3 children is present in my class. That is absurd. Okay. So there is a important aspect of these three classification, and that aspect is they do not include any fraction and they do not include any kind of decimals. Agreed? Okay. I hope this is clear to everybody. Now let's move on to the next part. Now, if you feel like you have understood the definition of natural numbers, you have understood the definition of whole numbers, and you have understood the definition of integers properly, then try to answer this question number 1. In this question, the number of positive integers n, we are looking for how many values of n. We are looking for how many values of n are there. How many values of n are there that will satisfy these two conditions. N plus 2 is less than equal to 0 and n square is less than equal to 4. See, we have, let's try to solve this question. First condition, that is n plus 2 is less than equal to 0, and the second condition is n square is less than equal to 4. Now let's talk about case number 1. We can consider only positive integers. We can consider only positive integers, right? And what are integers? Positive integers are 1, 2, 3, 4, 5, 6 and goes on. Complete numbers, right? So positive integers. So the smallest positive integer that I can assume here, or the smallest positive value of n that I can assume here is +1. Now let's check it out. Is this value satisfying these two conditions? put n equal to 1 over here. If I put n equal to 1 over here, it will become 1 plus 2. Is this less than 0? 1 plus 2, is this less than 0? No. So, the smallest value of n, even the smallest value of n is not justifying any of these conditions, then how come the bigger value? How come the next bigger value? Not possible at all. So, the answer of this question is option A, meaningly no such value exists. Right? No such value exists. Okay? So, there are 0 numbers of values. Zero numbers of value, meaningly I just want to count how many values of n I can assume here. So, I cannot assume n equal to 1 in question number 1, I cannot assume n equal to 2 in question number 1, I cannot assume n equal to 3 in question number 1. So, no such value exists, no such value exists, meaningly number of values that n can take is nothing, that is 0. That is why option A. Now, let us talk about question number 2, example number 2. The number of non-negative, please pay attention to the words, non-negative integers that will justify these two conditions. Now, non-negative, see, minus 3 is negative, minus 2 is negative, minus 1 is negative, but 0. 0 is neither negative nor positive. So, over here in this case we are looking for non-negative integers. So, in case of non-negative integers, n can be equal to 0, n can be equal to 1, n can be equal to 2, n can be equal to 3 and so on. Now, let us check it out, which value out of these will justify these two conditions simultaneously, right. So, see, if you put n equal to 0, if you put n equal to 0 in this first condition, it will become 0 plus 2 less than equal to 0, not justifying, right, okay, and n square equal to 4. If you put n equal to 0 here, again 0 is less than equal to 4. Okay. So, again in this case, we are not able to find out even a single value of n that will justify both of these scenarios. But let me make a change here. What if the sign was like this? Now, the first condition is n plus 2 greater than equal to 0, and the second condition is n square is less than equal to 4. One more thing that we know over here is n is a non-negative integers. So, according to this condition, n is a non-negative integer, meaningly n can take 0 as a value, 1 as a value, 2 as a value, 3, 4, and this goes on. Now, let us relate both of these together. Now, case 1. Let us take n equal to 0. Now, check it out. Is this satisfying this condition number 1? If I put n equal to 0 here, it will become 0 plus 2, and 0 plus 2 is greater than 0. It is justifying. Now, let us check it out. N equal to 0, is n equal to 0 justifying this condition? N square equal to 4, let us check it out. N square, that is 0 square, is less than equal to 4, yes. So, for n equal to 0, both of these conditions are justified now. So, n can take at least 0 as a value. Clear. Now, let us talk about case number 2. If you put n equal to 1, let us justify. N equal to 1, is it true for n equal to 1? If I put n equal to 1 here, it will become 1 plus 2, and 1 plus 2 is 3, which is greater than 0. Condition number 1 is justified, right? Condition number 1 is justified. Let us talk about condition number 2. N n square. N is 1. So n square meaning 1 square. Now 1 square is 1 and 1 is less than 4. So this value of n is also justifying both of these conditions. Now I can say n can take at least 2 values here. N can take at least 2 values here. Now let's talk about next case. Case number 3. Let's take n equal to 3. If I put n equal to 3 in these two conditions, so the first one will become 3 plus 2. 3 plus 2, which is 5. 5 is greater than 0, justified. Now n square is 3 square. N square is 3 square. Oh sorry, n equal to 2 ki jagah let's talk about n equal to 2 first. N equal to 0, n equal to 1, n equal to 2 first. Huh? Now put n equal to 2 here. If you put n equal to 2 here, it will become 2 plus 2, 4. And 4 is greater than 0. First condition is justified for n equal to 2 also. Now let's talk about this second case. N square is less than equal to 4. N square meaningly 2 square. 2 square is less than equal to 4. Now 2 square is 4 and 4 is less than equal to 4. This is true again. Why? Because this is less than equal to. If less than, then it is okay, and if it is equal to, then it is okay. So I got 3 values of n. First value of n 0, second value of n 1, and third value of n 2. So there are 3 values. If I make this small change, then n can take 3 values. Answer will be 3. But if you reverse the sign, answer gonna be 0. Now I hope you get the logic behind it, huh? Let's move on. Right now we are just learning that how well we have learned what are natural number, what are integers, what are whole numbers, huh? Now let's talk about this question. How many integral solutions are possible for this equation where x is an integer? Where x is an integer, right? Now, see, first of all, see, examiner is saying the x is an integer. If x is an integer, it means x can take negative infinity to -3, -2, -1, 0, 1, 2, 3 till positive infinity, any of these values. X can take any of these values, right? The first thing that we need to be careful over here. Now the second value. See, second thing, how many integral solution of this equation are possible? Meaningly, this 18x square plus 9x plus 6 divided by x, this must be equal to integer. Integral solution means this must be equal to integer. Meaningly, you can use any value of x out of these, put that value over here, and your answer must be an integer. Your answer must be an integer. Now appearance wise, it might possible that some of you will say answer is infinity, right? And might possible that some of you will say, sir, it is not possible to calculate at all. But guys, if you know the basics right, then this question is doable. This question is doable. Now please pay attention. See, this is your step number 1. Let's talk about step number 2. In step number 2, can I write this whole equation like 18x square upon x plus 9x upon x plus 6 upon x, and I want this to be equal to an integer. Integer meaningly a complete number. It could be -3, -4, +3, +4, any number. Now let's solve it further. X and this x square will get cancelled out. I will left out with 18x only. This x and this x will get cancelled out. I will left out with 9 only. Now 6 upon x is the remaining part and it must equal to integer. See, I can use only integral values of x here. So until or unless x is integer, this complete part is definitely an integer. Meaningly, if you put x equal to 0, if you put x equal to 0, it will become 18 into 0. 18 into 0 is 0, which is an integer. If you put x equal to 1, right? So 18 into 1 is 18, which is an integer again. So this is what I am saying right now. Until or unless your x is an integer, definitely this I, this whole term 18x will be integer. Okay. Now plus 9 is itself an integer. So my task is to convert only this value into integer. My task is to convert only this value in integer. If I do that, then integer plus integer plus integer will definitely be an integer. For example, 2 is an integer, 2, 3 is an integer, 3, 4 is an integer. So 2 plus 3 plus 4 is what? 9, no. And 9 itself is an integer. Getting it? Okay. So our task is to convert this 6 by x into integer by assuming some integral values for x. Now listen, if you put x equal to 1, this equation will become 6 by 1, which is equals to 6, and 6 is an integer. So I'll consider this value. Now if you put x equal to 2, it will become 6 by 2, which is equals to 3, which is an integer again. If you put x equal to 3, it will become 6 by 3, which is 2, which is an integer again. But you cannot use x equal to 4. No. Why? If you do that, 6 by 4 is what? You will get answer in decimals. I want this term to be integer. You will get answer in decimals. So x equal to 4 is not allowed. Similarly, what if you put x equal to 5? 6 by 5, if you divide 6 by 5, will you be getting any integer? No. You will get a fraction. You will get a decimal. Not allowed. Because I want integer. So the next value that will justify this part will be x equal to 6 itself. So 6 by 6 will become 1. So I can see I have 4 values now. 1, 2, 3, 4. If I use these 4 values here in this equation, definitely my answer gonna be an integer always. Right? 4. Now, is this the only possible case? Are these the only possible case? Are there some other cases possible? Let's talk about it. What if you assume x to be equal to minus 1? Your equation 6 by x will become 6 upon minus 1, which is equals to minus 6 is an integer again. What if I do x equal to minus 2? 6 upon minus 2, minus 3 is an integer again. What if I take x equal to minus 3? 6 upon minus 3, minus 2, integer again. What if I take x equal to minus 6? 6 upon 6, 6 upon minus 6, minus 1 is an integer again. So, to justify the given condition, how many values x can assume here? How many integral values x can assume here is 1, 2, 3, 4, 5, 6, 7, 8. 8 values x can assume here. That is why the answer is D, option D. Am I clear, guys? Now, you might be wondering, sir, why are you discussing such hard problems with us? Why? See, there is always a need that has to be served. Remember it. See, what was the need? What was the need for discussing this difficulty? The need was this problem that was there in your 2023. This problem. Please read this problem carefully. Examiner is more interested in concepts rather than tricks. He don't want you to utilize any kind of trick. He wants you to be good with concepts. He wants you to understand what are natural numbers. He wants you to understand what are whole numbers properly from the very basic. So see, the reason behind solving that problem is this question that was there in 2023. Read the question carefully. What examiner is saying? Examiner is saying let x be a positive integer. What do we mean by it? X is a positive integer. What do we mean by it? X is a positive integer, meaningly x can take any value such as 1, 2, 3, 4, 5, 6, this goes on till infinity. X can take any one positive value out of it. Integer is given now, so you cannot include decimal, you cannot include fractions because integer is written here. Remember. Now the next thing, let x be a positive integer such that 7x plus 96 is divisible by x. Meaningly 7x plus 96 when divided by x, you will get a complete number here. What do we mean by divisibility? I would say if you want to divide 18 by 9, you will get 2. So I can say 18 is divisible by 9 because you are getting a complete number in the result. Right? Now 24 divided by 6, you will get 4 in the result. So you can say 24 is completely divisible by 6. In the similar fashion, in the similar way, examiner over here is saying x is divisible by 7x plus 96 is divisible by x. It means if you do this, then the result that you are gonna get will be a complete number. Complete number, meaningly integers. Your result over here gonna be an integer because integers are complete numbers. Getting it? Okay. Now let's solve this further. Now 7, I can write this equation like 7x upon x plus 96 upon x. It must be equal to integer, isn't it, guys? Now this x and x will get cancelled out. You are left out with 7 plus 96 upon x. I want this to be integer in the end. So 7 itself is an integer. So I just have to convert. I just need to assume those values of x. I just have to assume those values of x that will convert this 96 by x into complete integers. So see, if you assume x equal to 1, it will become 96 upon 1, and 96 upon 1 is 96. So 96 is an integer. So if you do x equal to 2, if you assume x equal to 2, then this 96 upon x will become 96 upon 2, which is 48. So 48 is an integer. So you can assume x equal to 1, you can assume x equal to 2. Similarly, you can assume x equal to 3 also. So over here, you can assume all those values that will divide 96 completely. Meaningly, you will write down all the factors of 96 because all the factors of 96 will divide 96 completely. Now, so basically, see, if you put x equal to 1, 1 is a factor of 96. X can be equal to 2, 2 will divide 96 completely. X can be equal to 3, 3 will divide 96. 4 will divide 96, 6 will divide 96, 8 will divide 96, right? Then after it, 12 will divide 96, 16 will divide 96, 32 will divide 96, right? 1, 2, 3, 4, 6, 8, 12, 16, 32. There are other values also. 48 will divide 96. Okay, 96 itself is divisible by 96. So how many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One value is missing. 24. 24 will divide 96 completely. So how many values are there? 12 values are there. But basically I can say, see, there are 12 factor of 96. For 12 values of x, this part 96 upon x gonna be an integer, hence this complete part will become an integer also, right? I hope guys this is clear to everybody. Huh? So this problem was there in PY, like this problem was there in CSAT 2023. Let's talk about the next part. See, now we have learned what are rational, what are natural number. We have understood what are whole numbers, and then we learned what are integers. Now the next part that we should learn is rational number. Now anybody in the class who can define me what are rational number? Who can define me what are rational numbers? So it might possible that some of you will say, sir, those number that can be written in PYQ form, where Q is not equal to 0. It might possible that some of you will think, sir, those numbers that are can be written in PYQ form and where Q is not equal to 0, these are rational numbers. I agree, but this is not the complete definition. I would say this is only 33.33% of the actual definition of rational number, right? So this is only 1/3 of the actual definition. So listen carefully. What is the complete definition? See, PYQ, Q is not equal to 0. Second part. Over here, your P and Q both must belongs to integers. Both must belongs to integer. First of all, write it down, then I'll explain you. Why so? I'll explain you, don't worry. Now next part, third part. And the SCF of P and Q must equal to 0, not must equal to 1. Now, your definition of rational number is completed. These are the 3 conditions that you need to check to define whether the given number is a rational number or not. Now, we all were aware of this first definition. Reason is because we have included rational numbers so that we can write fractions or we can write decimals. Pretty easy. Okay. Now, why Q cannot be equal to 0? Now, reason is, see, if you do this kind of scenario, 1 divided by 0, it is not defined in mathematics. This is not defined in mathematics. It might possible that some of you will say, sir, 1 by 0 is infinity. Then 2 by 0 is infinity. Those who will say, sir, 1 by 0 is infinity, then 2 by 0 will be infinity also. See, over here we have infinity on the right hand side. So 1 by 0 must equal to 2 by 0. So by mathematics I can prove 1 equal to 0, which is not true. So do remember guys, 1 by 0, 2 by 0, anything divided by 0 is not equal to infinity. It is just not defined. Anything divided by 0 is not defined. Remember it. I have seen so many engineers, I have seen so many mathematicians making a mistake over here, right? So Q must not equal to 0. Reason is, if Q becomes equal to 0, then this thing is not defined in mathematics. Okay. Now why this P and Q must belongs to integer? Remember your good old days when you were in, I think, 4th or 5th standard. You solved a problem and in the end you wrote it like this. You solved an example, you solved a complete question, and in the end you wrote it like this: 2.4 divided by 1.7. You just left out your answer like this. Remember, teacher would say, or what teacher will do, if this question was of 5 marks, teacher will cut 1 mark out of that. The reason behind that was because whenever we write an answer, we have to write that answer in a pure rational form. In this case, your P is 2.4, your Q is 1.7. Now I told you P has to be an integer. Over here P is 2.4. 2.4 is not an integer. Over Q is 1.7. 1.7 is not an integer. Try to understand this part, guys. So this is not the pure form of writing a rational number. 2.4 divided by 1.7 is not the pure form of writing a number. So what you can do, just divide, multiply by 10 in the numerator or 10 in the denominator. So 2.4 into 10 and 1.7 into 10. Now your answer 24 upon 17. This is a pure rational number. 24 by 17. This is a pure form of a rational number. I hope guys this is clear. Now, so this is the second part of your definition. Now third part. Again, remember your good old days when you were in, I think, 4th or 5th standard. Again, you solved a problem. You solved a problem very meticulously. You solved it properly. You have done every bit of calculation proper and in good sense. But in the end, what you just did, in the end, you left out your answer like this, 10 by 16. And you were happy you will get 5 out of 5 marks. But guys, again, in this case, if you left out your answer like this, definitely your teacher will cancel out 1 marks again. Out of 5, you're gonna get only 4 numbers or 4 marks. The reason for that is because in this case, your P is 10. In this case, your Q is 16. But if you calculate their SCF of P and Q, if you calculate their SCF is not 1. Their SCF is 2. That is why this is not the pure form of a rational number. 10 by 16 is not a pure form, right? So, if you want to write down the answer completely, if you want to get 5 out of 5 marks, then cancel out some part of, from the numerator and from the denominator. 2 5s are 10, 2 8s are 16. So 5 by 8 is the right answer. 5 by 8 is the pure rational number. Why? Because your P is 5 now, your Q is 8. And what is the SCF of P and Q? Highest, SCF stands for highest common factor. That highest number which will divide 5 and 8 simultaneously, and that highest number is 1. Hence, 5 by 8 is the right answer, not 10 by 6. 10 by 16 is equivalent answer, but not the right answer. Getting it? Okay. I hope this definition of rational number is more clearer now. But this is not the only part. This is not the only part. Why? Let me give you the reason behind it. This is not the only part. Now, what kind of, tell me one thing. What kind of number 1 by 3 is? Sir, 1 by 3, it's a P by Q form. So, I am asking 1 by 3, what kind of number it is? You would say, sir, our P is 1, our Q is 3. So, this number 1 by 3 is justifying this condition number 1, where Q is not equal to 0. Yes, justifying condition number 1. Okay. What about condition number 2, sir? Yes. Sir, P is 1, Q is 3. 1 is an integer, 3 is an integer. So, condition number 2 is also justified. What about this condition number 3? SCF P and Q 1. SCF, highest common factor of 1 and 3. What is highest common factor of 1 and 3? 1 itself. Hence, 1 by 3 is a rational number. Agreed? No? Okay. Now, if 1 by 3 is a rational number, then just solve this. If you solve this, you will get 0.3333333 goes on till infinity. Now, just try to learn one thing, guys. If you divide 1 by 3, you will get something like this. Don't pay attention to your calculator, do the actual division. It might possible that after few digits, after writing 3, like 5 or 10 times, the calculator will stop answering. But if you do this properly, then you will find out this 3 will never goes off. It will just repeat itself over and over and over again till infinity. We cannot even count it. Now, if our left hand part, if our left hand side was rational number, if our left hand side was rational number, then definitely our right hand side must be a rational number. Our right hand side must be a rational number, because left was rational, then right was rational again. Although politically it is not it is not true, left is left, right is right, but let it. Guys, 1 by 3 is a rational number and 0.333 this goes on till infinity. It's a rational number again, because if left is rational number, then right must be a rational number. Huh? Now listen, see, I hope this is done. Now listen, now so there is one more way. So there is one more part of the definition of a rational number, and that part is, please write down, that part is those decimal fractions. The part is those, please write it down, those decimal fractions that are non-terminating, जो close नहीं होंगी, non-terminating and repetitive or recurring. So non-terminating and reoccurring. Non-terminating and reoccurring decimals are also called rational numbers. So 0.3333, this goes on till infinity, this is a rational number, right? 0.16161616, this goes on repetition till infinity, is a rational number again. It's a rational number again. 0.352, this goes on till infinity, it's a rational number again. Okay, I hope guys this is clear. The fourth important part. So those decimal fractions that are non-terminating and recurring are called rational number also. Now why we are learning this? Because there was a question in CSAT. Okay. So let's talk about this terminating and non-terminating but recurring decimals. Oh, we just have learnt one thing. See, we have learnt one thing just now, right now, that was, it was like, give me a second, if somehow you come across decimals like 0.52525252, this goes on repetition till infinity. So these kind of decimals are rational number. These kind of decimals are rational numbers. We just learnt this. Okay. Now this can be written as 0.52 bar. Now please pay attention. The bar is present over 2 digits. The bar is present over 2 digits after decimal. The bar is present over 2 digits after decimal. So what is the meaning? What is the meaning of a bar after decimal? It means those 2 digits are repetitive. 0.52 bar means 5 and 2 is repetitive till infinity. Suppose you come across some scenario like 0.132 bar. Now please pay attention. Bar is over 32 only, so it means 0.132323232 goes on till infinity. The bar over a digit after decimal means that digit is repetitive. Getting it? Now, so 0.525252 can be written as 0.52 bar, and it's a rational number. It's a rational number. Now, listen, next. Now, what kind of number 1 by 2 is? What kind of number 1 by 2 is? It's a rational number. It's a rational number. Why? Because your P is 1, your Q is 2. Satisfying condition number 1, Q is not equal to 0. Satisfying condition number 2, both are integer, 1 is integer, 2 is an integer. Satisfying condition number 3, highest common factor of 1 and 2 is 1. Okay, all these conditions are justified. Now, if you actually divide 1 by 2, you will get 0.5. And what kind of decimal this 0.5 is? What kind of decimal this 0.5 is? This 0.5 is terminating decimal. This 0.5 is terminating decimal. क्योंकि इसके बाद ये repeat नहीं करेगा. It's a terminating decimal. So again I can say that same thing. If your left hand side 1/2 is rational, then definitely 0.5 is rational again. 0.5 is a rational number again. So terminating decimals as well as non-terminating but recurring decimal. Terminating तो होती ही है, but non-terminating and recurring decimals भी rational number होती हैं. Am I clear, guys? Clear. Now please note it down. Hurry up. Make a note of it. Okay. I hope you have done. Let's move on to the next part. Okay. Now the part is, see, we all know that if something like this is there, if you have scenario like 7.2 and I ask you to convert this 7.2 into a fraction. 7.2 is a decimal and I ask you to convert this 7.2 into a fraction. So what we people generally do? What we generally do? Sir, it's a, what kind of, first of all, what kind of decimal it is? This, sir, this is a terminating decimal. This is a terminating decimal. So if it is a terminating decimal, then 72 divided by 10, this is what we generally do, right? For this decimal we write 1, and how many digits are present after decimal? How many digits are present after decimal? 1 digit is present after decimal, so those many zeros. Now cancel it out. 2 3s are 6, 2 6 are 12, 2 5s are 10, so 36 by 5. So 7.2 is 36 by 5 in fraction, right? Okay. Now this was a very easier part for us. What about if you come across scenario like 0.16 bar? We all know what is the meaning of 0.16 bar. The meaning of 0.16 bar is 0.1616161616 and this goes on till infinity. Now by general rule, if you want to convert this number into a fraction, what you people will generally do? Sir, we will write this 16 till infinity in the numerator, divided by 1 0 0 0 0 0 0 till infinity. Now have you ever seen such kind of scenario in the real life? In mathematics, have you ever seen? No. So if you want to convert such kind of fractions, such kind of decimal into fraction, then what do you need to do? Please be very careful and listen to me carefully. Over here, kindly listen to me carefully. You want to convert 0.16 bar into fraction, right? So what you will do? Write down all the digits that you can see in the numerator. Write down all the digits that you can see after decimal in the numerator, divided by those many 9 as the number of digits below bar. How many digits were present below bar? 2 digits were present below bar, so write 2 9. Now 0.16 bar is actually equal to 16 upon 99 in case of fraction. Now cross check your calculator. Divide 16 by 99 in your calculator. Check it out. You will find 0.161616 and this goes on, right? Okay. Now let's say so I hope this is clear to everybody, no? Now this is not the end. You need to cancel out something from the numerator and denominator if we can, like 99 is 3 into 11, 9 into 11, so no. 16 upon 99 is the right answer here. Now let's say you come across scenario like see, you want to convert, listen carefully. You have scenario like this, 0.349 bar. 349 bar. So what you will do? In this case, you will write down all the digits that you can see after the decimal. Write down, please listen to me, write down all the digits that you can see after the decimal. 349 minus those digits that are without bar. So over here 3 was without bar, so write down 3 divided by those many 9s as the number of digits without bar. Those many 9 as a number of digits with bar. Those many 9 as a number of digits with bar, and those many zeros as the number of digits without bar. As the number of digits without bar. Clear? Now solve this. 349 minus 3 is 346 by 990. Now we can cancel out with 2. 2 1s are 2, 2 7s are 14, 2 3s are 6. 2 4s are 8, 2 9s are 18, 2 5s are 10. Yeah. We can cross check it again, 90, 90, 49, 49, yes, it is okay. Clear guys? Now if you, we end up with 173 upon 495. Now if you can cancel it out further, go for it. If you can cancel it out further, go for it. Right? So you need to you need to short it down until or unless you get a pure rational number. Okay? So this is how you're gonna deal with it. Now let's say, sir, what if the scenario is a bit different? Like what if scenario is a bit different? For example, what if scenario is like 0.1352 bar. Now listen, 0.1352 bar. So write down all the digits that you can see. 1352. Now subtract those that are without a bar. Subtract those that are without a bar. Divided by. Write down those many 9 as the number of digits with bar. Write down those many 9 as the number of digits with bar, and those many zeros as the number of digits without bar. So over here we have 2 digits without bar, so 2 0. Now solve this, get your answer. Right? I hope guys this is clear to everybody. There is no doubt in it, huh? Okay. Done? Now solve this further. The calculation part you can do, I know. Can I erase it? No? Huh? Okay. Let's talk about one more scenario here. See, for example, you come across scenario like this, 1.246 bar. Now, in all the question that has been discussed before this question, there was no digit present before decimal, but over here we have 1. Now what to do, sir? The thing is very simple. See, I can write this whole stuff like 1 plus 0.246 bar. Agreed? Now write down this one as it is. What about this case? This is similar to what we have just discussed, right? Write down 246, write down all the digits that you can see after decimal minus those digits that are without bar, divided by those many 9 as the number of digits under the bar, and those many zeros as the number of digits without bar. Solve this. 1 plus, it will become 242 upon 244. It will become 244 upon 990. Now solve this, you will get the answer. Solve this, you will get the answer. Okay. So can I erase it now, Hannah? I hope. Now we have discussed all the scenarios for terminating, non-terminating and terminating, as well as non-terminating and recurring cases. Now let's talk about one more very important case over here. I have written this thing over here also, that how to convert this number into the other form. This is a question, but I just want to discuss this very case first. Now what is the meaning of case logarithmic? This is bit typical. UPSC hasn't asked any question from this part, but UPSC has asked that thing, the bar after decimal. So it might possible that in near future UPSC can ask question from this case also. Now what is the meaning of case logarithm? See, now sometime in mathematics we do come across numbers like, number like 2 bar 0.46. Now the meaning of this particular case is completely different. It is not similar to the previous case. In the previous case we had decimal, we have bar over a digit after the decimal. In this case we have bar over the digit before decimal. The meaning of this case is completely different. The meaning of this is, this first part 2 is negative, and this remaining part 0.46, the remaining part 0.46 is positive. The meaning of this representation is this. Okay. Now let me explain this thing once again with one more example. Like suppose you have scenario like 3 bar 0.59. The meaning of this, it can be written as 3 bar plus 0.59. It can be written as 3 bar plus 0.59, and this meaning of 3 bar is negative 3 plus 0.59. So it's just a representation that we use in case of mathematics, right? And this representation is used in case of logarithm. Logarithm is not a part of your syllabi, but this representation could be. So that is why I felt we should discuss this. Okay. And now solve this. Now see, there is one more scenario. Suppose you have number like 2.76. Now please pay attention to this case. In this case we do not have, any bar over any digit. So it simply means minus 2 minus 0.76. This simply means this. But if bar is present, then meaning is different. Okay. So just keep these fundas in your head, guys. Just learning tricks will not solve the part, is not the solution here. Learning concept is the solution. So I am teaching you concept here. So this is all from my side for today. I hope you have understood what we have discussed over here. So thank you so much. Have a nice day. हाँ हो गया.